Here we're going to learn how to graph a tangent parent function. So one of the things to keep in mind with tangent is that if we compare it to our unit circle here, we see that tangent is just equal to y over x. I went over that in a previous video. So let's go ahead and just calculate our tangent values for these different points. And I picked these points on purpose. So here we just get 0 over 1, or just 0. And then we can do the same thing for each one of these points. So I'll go ahead and do that. So now that we've got that, what we can do is we can take a look at where it starts repeating itself. And what we're going to see is that tangent repeats itself kind of twice as fast as both sine and cosine did. So looking at that here, I can see that if I start down here at negative pi over 2, I'm undefined, then I hit negative 1, then I hit 0, then I hit 1, and then I'm undefined again. And then we're going to see that that pattern repeats itself once again. So if you recall, I went from being undefined to negative 1 along these kind of quarter of half marks or eighth marks for our entire circle. And then I do the same thing here. And then the pattern continues. And so what we're going to find is that if we want one full period of a tangent function, a starting point can be negative pi over 2, and then it starts repeating itself at pi over 2. And then we hit our important values, or at least easy to find values, at negative pi over 4, 0, and pi over 4. Remember, for a trig function, the period is kind of one full set of values where there is no repetition. And what we're going to find is if we just kind of plot these points out real quick, well, we can see that graphically, and then we'll formalize things a little bit. So when I say undefined here, you hopefully remember from previous videos, if I have something like 1 over 0, what that really means is kind of infinity, and I'm getting a vertical asymptote there. So I'm getting a vertical asymptote here at both negative pi over 2 and pi over 2. And so I'm going to go ahead and just draw those vertical asymptotes. And then I'm going to go ahead and just plot these quarter marks here. So if I travel to negative pi over 4, and you'll notice I made the scale every 2 of these is pi over 4. Negative pi over 4, I'm down at negative 1 here. And so let's just make that like 2 of these, so it'll be right here. And then I travel to 0. And then if I go one more quarter mark up to pi over 4, I'm going to be up at 1. And so similar kind of relationship, we're kind of oscillating around the middle, which in this case is 0, and then we're going 1 above and 1 below. And I should probably point out, this is for y equals tangent of x, our parent function. And then I can just plot it. Now, one of the things that hopefully you recall is as we travel toward a vertical asymptote, it's kind of like a force field. We're just getting closer and closer to vertical. And same thing here. It's almost like these little pieces of a parabola, similar relationship, not the same. And then in the middle, it kind of does this little curve here. It's not a perfect drawing, but it's close enough. And then what we're going to see is if we continue on to 3 pi over 4 here, which would be here on our graph, we're at negative 1. So getting a little bit sloppy here, but there it is, negative 1. And then we go to pi, which would be right here, and we're at 0. And then if we travel one more of these pi over 4 marks, we'd be at 3 pi over 4, which we can clearly see is up at 1. And so we're seeing that repetition now, because when we get back over to 3 pi over 2, Well, we're right back here at our undefined vertical asymptote. And so we're going to get another asymptote right there at 3 pi over 2. And we can go ahead and connect our curve just as we did in the previous one. These take a little bit of work to get used to drawing. I would recommend maybe hopping over to Desmos or a graphing calculator and just playing around with them and looking at the curvature of them. And of course, you could always plot more points if you want a more accurate graph. All right, and so what we're going to do is kind of formalize the behavior of this graph again. So we see that we have the start of a period at negative pi over 2, and then we have the end of a period at pi over 2. Remember, this is continuous, so I'm just picking a period. It doesn't have to start here. But really where we're seeing is they start and end where our graph is undefined, or we get those vertical asymptotes. So that can be a nice kind of touchstone to see where we're at. And then if we break it in half, so at the halfway point, we saw that we're right here in the middle, which in this case is going to be at y equals 0. But of course we can have vertical shifts, so that can change. And then for the first quarter mark, we're generally going to be one amplitude below. So in this case at y equals -1, and we saw that here. And then lastly, at our third quarter mark, we are just one amplitude above, or at y equals 1, and we saw that right here. And that's it. From there, we can use all of the transformational tools that we have from working with functions in general and transform the graphs as needed.